First-person controller systems are one of the most common mechanics in video games. And today I would like to show you how I personally make my first-person controller, as well as how in general you can make a first-person controller in Unity. So to start off, I've made a little test scene here. Not much has been added in here. I have a basic environment just to show some relativity whenever we are moving, and to show that we have movement working. So I have nothing else added in there. There's no scripts. There's just the scenes and materials that have the red and light blue I am showing here. So let's go ahead and start off. I usually like to create an empty object and reset its transform. I'm going to call this the first person controller. And I typically like to do an empty game object as the head that controls all the systems, so that the model, so if you have a player model or if you're just going to do a capsule like I am, can be completely separate from all the control schemes in the game. So all I'm going to add for the physics first person controller is a rigid body. Now this is going to handle our physics so that we do not have to reinvent the wheel and add gravity or handle gravity ourselves. And we can just use the already built-in system from Unity. So I'm going to go ahead and parent our main camera under the FPS controller so that we can obviously see. And I'm going to add a capsule collider so that our rigid body actually has collisions. So at the moment, not very much is added. It's just a sphere here with the camera on it. So I'm going to give this camera a little bit more height. But first I'm going to add some height to our actual capsule collider. So now it's more of a capsule looking object here. And then I'm just going to move the main camera up to a more proper height. So you can kind of see there as to where it is. It's kind of around the head area. So all we got to do now is add a FPS controller script. We'll just create an add. And then we'll just open this up. So we need a couple variables to start with. So obviously you need a walk speed, and we'll set that to 5. And you also need a run speed, and we'll set that to 10. Next, we're going to want to have access to our main camera, and we could just grab the transform here of the main camera. However, I'll just go ahead and grab the entire main camera object. And then what we're going to want to do is at some point we're going to be able to rotate this main camera. And so we have to store some sort of value of how we're going to rotate our main camera. So I'll just store a cam rotation here. And we'll set it to 0. Along with this, we're going to want to be able to jump, obviously. So I will add a jump force. And I'll set that to 10 as well. So all we have left to do is start writing some code. But before we do that, there's also one other thing we might want to do, which is grab some instances of our rigid body. Moving with physics is a complicated system, and so you give up some of the snappiness whenever you move via forces and pushing your object around. So how I like to do my rigid body movement is by actually modifying the velocity vector that the rigid body contains. And that velocity vector basically tells Unity and the physics engine how we are supposed to move within the next few frames. So we want to be able to get a reference to our rigid body. So we're going to go ahead and get RB is equal to get component rigid body. And we'll just close that off. And then we're going to want to start grabbing some input values. So the best way to store input is by actually having a vector for the input. And the reason why for this is because we're going to be handling our input separate from our actual movement. physics is updated on a different loop than the regular frames per second update function is. So it is actually on fixed update. So we're gonna write, if I can write it here, fixed update. And so fixed update is going to be handling our actual movement, while update is going to be handling our inputs. So we're going to need to store some inputs. So I'll just add inputs there. And then in our update method, we're going to get input. And so of course we're going to need to create a method, the same header. So an S there. So we're going to go ahead and grab our inputs. So really easy way to do this is by using the already existing axes inside of Unity. So we're going to go ahead and grab a new vector2, input.getAxes. And so this is going to be going along our x-axis, our horizontal axes. So we're going to be wanting to be grabbing the horizontal, while for the other one, it is going to be along our vertical, because we're going to be going along our Z direction with that. Along with this, so before we get into some later things, we're also going to want to handle mouse movement. And we're going to be doing this actually inside of the update method, because your mouse movement is not running on the fixed update. So we want it to all be handled within our update method, so it is as fast as whenever your player is moving their mouse. So let's go ahead and create a method here. And so the next thing to do is to grab mouse movement vector. And so the easiest way to do this is similar to our inputs. We're going to be grabbing a new vector2, input.getAxes mouse x, input.getAxes mouse y. And so now there's a couple things you're going to want to do with this vector. So one is that we're actually going to be moving our player by having the whole object itself spin along its axis. So let me make this more apparent with a capsule. Move it up by one, and we can actually just remove off the capsule collider because it is actually on the player itself. So this is just our model, and this is what I was mentioning earlier, is that I like to have all the functionality in the top here, in the top level, while everything below is more or less just models. So having our player here, what we're going to want to do is we're going to want to have the camera itself swivel up and down like this. And you kind of see it down here in the camera preview. You can kind of see we go up and down. However, the actual right and left movement is based around moving the entire player. So like that. And the reason we do this is because if you were to move just the main camera around the y-axis, even though it looks good down here, you'll have weird movement. And also along with that, if your model isn't just a capsule here like mine is, your character will never actually rotate, and so they'll always walk in some singular direction, and it looks strange if you have your player who's running forward actually, moving from the side. So let's jump back into the code. And so all we have to do in order to make our player rotate around the y-axis is just by grabbing the current rotation of our player and rotate it by whatever our mouse vector tells us. So we're wanting to rotate along this direction here, which is our horizontal direction, which is the mouse X. So all we have to do is take the transform.rotation, which is our transforms rotation, and set it to a quaternion, which is how Unity handles rotations. And then we say Euler, because we're going to pass the quaternion function a Euler angle, since that is how humans like to actually read it. And we'll just give it a new vector 3. And now this part's really easy because all we have to do is worry about one single axis, which, as I've said before, is just the y-axis. So these other two, x and z, can both be 0f. And so now we only have to add some code here in order to actually make it rotate. So if we go ahead and say transform.rotation.eulerangles.y, and so this grabs our current rotation along the y-axis for our player, and we're going to add in some mouse movement .x, which is our horizontal direction, multiplied by some sort of mouse sensitivity. Since the mouse movement is very low values, since it's frame rate independent, we're going to want to bump up the speed a little bit by multiplying some sort of mouse sensitivity. So we'll just add a value up here of mouse sense, and I'll just say it's 7f. So that will now should work if I just add in a semicolon and save up our project, and now we can test it. So at the moment, you can see I'm now rotating only around one direction, and so now next we want to make the up and down direction move. So in order to do that, we're going to actually be modifying our camera. And so in order to do that, all we have to do is say main cam .transform .local rotation. And the reason we do this is because since our character has the camera under the actual object, so it's parented under that object, its rotation needs to be in terms of the local rotation. So in terms of the parent. So more explanation on that is that basically the rotation handled under here is going to be different from the world space. Obviously, if it rotates this way, it's now different in terms of world space. So if I unparented this object and rotated it the same direction it is currently looking, it's a different rotation. However, under the player, it's 0 still. So that's its local rotation. Its local rotation is 0. Yet its world space, it's different. It's a different value. So we have to say local rotation here because we want these values to be in terms of the parent's already existing rotation. And the parent, of course, is the actual player, which is the transform here. So we're going to say quaternion dot Euler new vector 3, and now we need to figure out which axes we're going to be rotating on. So we want to rotate in terms of, so if I go back to 0 with this, we want to rotate in terms of this direction here to look up and down, which is along the x direction right here. So all we have to do is not worry about any of the other directions because those are going to just be 0, and we just want to worry about the x direction. So we want to take some sort of information, so the camera rotation, similar to what we did here, we're going to add on to the already existing rotation, and we're just going to have that value added onto. So mouse movement dot y, since we're going to be moving up and down, times the mouse sensitivity. So let me go ahead and bracket that up, and then we can only, all we have to do is add in this camera rotation here. And so now we can save that up, and we can actually run this, and this should work. However, there's one other thing we're going to have to do, and that is get a actual reference to our main camera. Since we're using it down here, but we have not yet set it, we had to set it here, which is just equaling it to the public variable, the public camera variable of main, which is just grabbing this right here. So then, this should work. So if I look, you can see it's kind of inverted. And so in order to change that inversion, we just have to say that it's negative. This is because Unity apparently calculates it from a different corner. So going up and down is actually flipped. So let's go back into there. And we can now see that if I go up, I look up, and if I go down, I look down. Left is left and right is right. Now there's one other thing we have to check and fix, is if I just keep going up, I go all the way around, and same if I go down. So in order to fix this, all we have to do is do a couple checks. So the first one is really easy. We want to clamp our rotation between a negative and positive value, of which is going to be our min and max rotation. So we have to define our minimum rotation, which is actually going to be 90. If we check back in Unity, we can actually see that going down. So what we would expect to be the minimum, because you're looking down, is actually positive. So that is going to be our minimum rotation, while our maximum rotation is going to be equal to negative 90. So now then, if we have these two things, we just need to clamp our rotation between this. So we can just say clamp, and then we're going to do our cam rotation between the max cam rotation and the min cam rotation. Now I know it looks strange being backwards like this from min to max, being backwards like that. However, that's just because it's negative 90 to 90. So now if we run back into Unity, we can see that if we look up, we stop, and if we look down, we stop. So now, the next thing we want to do is actually something that I really enjoyed doing, and that's locking the cursor. So lock state locked. So this very basically just locks the cursor into place. So if we run back in there, you can kind of see that, well, my cursor is no longer visible either. However, just to ensure this for a built game, we also want to say cursor.visible is equal to false. So this will make the cursor no longer visible either. In the editor, it makes it invisible. However, I believe once the game is actually built, it will actually stay visible on your screen. So we want to make sure it's invisible, so we just turn the visibility of the cursor off. Next, we want to start using our inputs. So already we are handling inputs. However, we're not doing anything with them. So in order to start doing something with them, we're wanting to go to the fixed update method, which is where we're going to be changing the speed vector, the velocity vector of our rigid body. So in order to do this, we want to do vector3 movement, and we're going to say that this is equal to transform.forward times the inputs dot y. And we're going to want to add this to transform dot right times inputs dot x. So the reason I'm doing this in this manner is that let's take into instance that we're looking in this direction, which I believe is fully along the z direction. If we take our forward vector, it's going to spit out a 1 along the z direction. So it'll be 0, 0, 1. In terms of vector 3, it'll be 0, 0, 1. If I press forward on my keyboard, that means that we'll multiply our input, which for forward it will be 1. So for vertical it'll be a 1, and horizontal will be a 0. And it will take our transform.forward and multiply this by 1. And now this will actually be a vector 3. This transform.forward is a vector 3. If you just hover over that, it says returns a normalized vector representing the blue axis of the transform in world space. So if I'm looking along just the z direction, if I'm looking just along this direction here, we can see that it will always be a 1. So it'll be this whole addition here will be a new vector of 0, 0, 1. If we multiply our right, it will be a 1. So let's just go back over here. So the right direction, which is this direction up here, it will actually go 1, 0, 0. And so now if we multiply these, right? If we multiply these and then add these together, so same as before, if we're pressing along the horizontal, this will be a 1, and then it will just say 1 times a vector that says 1, 0, 0. So if we multiply these values and then add them together, let's assume for a second we're pressing just on our forward key. So this will be a 1 times a 0, 0, 1 added to a 0 times a 1, 0, 0, which will just be 0. So this will just be a 0, 0, 0 plus 0, 0, 1, which will end result just be a 0, 0, 1. On the other hand, if you do it with just a right or left, it'll go 1, 0, 0 plus 0, 0, 0, so it'll just be 1, 0, 0, so it'll be fully this. Now, if we mix this up, so if we're pressing, like, let's say, for example, a W plus D, so a forward plus a right, it will be 0, 0, 1 plus 1, 0, 0, which is 1, 0, 1. And this is why I'm doing it like this. So it makes it very easy to just add these vectors up, and now we'll start moving along the direction we need to. So if we were going from 1 and 1, it would just be going along this diagonal here. So back into what I was doing. So this gives me the movement vector in terms of right and forward. And so we want to do a very basic check here to see if we're pressing the shift key. So, and the reason we're doing this is for sprinting. So if we're pressing the shift key, we're going to say movement times equal to run speed. Else, so if we're not pressing the shift key, movement times equal to walk speed. So now then, this will give us values in terms of our direction multiplied by our speed. So scaling our movement along our direction. And so now this is exactly what we're wanting. We're wanting to take the direction we are going to be moving due to our current direction, and then multiply by our speed and stuff. And this will allow us to modify the rigid body directly and change our movement and direction and stuff. So we're going to take our reference to a rigid body, and we're going to say velocity. It's going to be equal to a new vector 3. So we're taking the current velocity that's there, just deleting it and replacing it with this new velocity. And we're going to say movement.x. I'll come back to this one in a second. And then movement.y. Not y, z. So now our new velocity is going to be equal to whatever our inputs are. So whatever our inputs are times whatever whatever scale we're going at. So the scale is either run speed or walk speed. Now what about this middle one here? So this middle one is the z direction, which according to this movement vector we never change. However, since this is a physics-based system, a physics-based movement with our rigid body here, we don't want to have to handle gravity ourselves. What's good about this is that since gravity is handled for all rigid bodies automatically, assuming that this used gravity is marked, which ours is, since ours is marked with used gravity, we could actually just go RB, which is our rigid body, dot velocity, dot y. And so now it'll just use whatever's already there. So it'll take the vector and use what's already there and just update it. So basically we're just taking our X and Z direction movement. And we're going to leave our gravity and whatever modifications we have along our Y direction as they are. So this makes movement much, much easier. So now if I move forward, nothing is happening, seemingly. But the reason why is because we have to freeze some of our rotations. And the reason why is because otherwise our pill-shaped body here will just kind of fall over. So after we've frozen our rotations and we go back, if we try moving forward in any direction, you can see that we're actually moving. So as I showed there, we have to freeze the rotation because otherwise this guy will try to topple over and abide by the laws of physics. However, we don't really want him to abide by those laws of physics. We want him to abide by our laws of physics. So no angular rotation is being applied now. So if I press shift, as you kind of see it there, I kind of run a little faster. So if I go like that, you can kind of see. So now then, what we want to do now is we want to add jumping, which is obviously one of the most important things in video games that require jumping, is to be able to enable jumping. So all we have to do for this is we have to first determine what key we're going to be having for jumping. So I'm going to use spacebar, which is very common. And so now in our get inputs, we want to modify some sort of Boolean value that tells our physics loop to jump. So we can't just pass a value from our update method into our fixed update. Since they run differently at different time steps, we're going to actually have this update method call something and change something, and then the physics update is just going to use that information later, which is what it's currently doing. In our update method, we're getting our inputs, and in our fixed update, we're using those inputs. So they're not being passed from one to the other, they're being passed by just modifying some sort of variable we already have. So let's go ahead and say if input.getKey down keycode.space. So if our spacebar is being pressed, we want to modify jump, and obviously it wants to do jump force, jump is equal to true. So let's go ahead and create this jump variable. So we'll just do it right here, and we'll just set it equal to false. So if we run back, nothing is going to happen, obviously. However, behind the scenes, whenever I press space, the jump variable is being changed to true, and nothing ever changes it back to false, obviously. So let's go back into our fixed update now and use this variable given to us. So it's a very simple check. If we just do if jump, so if the jump variable is true, so if you just leave it like this, it means is true. If jump, then we're going to take our rigid body dot velocity and we're going to set it equal to a new vector 3. And this is where we're kind of going to do the exact opposite that we did down here. So down here, we changed our velocity based off our inputs for our WASD buttons. So here we also left the velocity the same, so that gravity is still being handled by the physics engine by itself. However, here we're going to do the exact opposite. We're going to say rigid body dot velocity dot x, and we're going to keep the old velocities. However, in the middle here, so our y velocity, we're actually going to set it equal to our jump force that we have defined above. So up here we have jump force. So now that that works, we're just going to say jump is equal to false. So now we have a loop here. We have an input that changes something to true, and we have a condition that checks it and then turns it back to false. Waiting, and so now jump will be waiting for the next time it's press space. So let's go ahead and check this out. And if we just jump, you can see that we jump up and we fall down. And we can move, we can jump and they're separate from each other. And if we just left, and we can kind of control ourselves in the air. And air control is something that can be changed as well through our code, and how we're handling our movement can be changed for later in order to either enable or disable air control. And so now we have a very nice system in place that's using physics engine that's already in place from Unity, and instead gives us a very nice snappy feeling. So if I just stop moving right now, we have a nice immediate snap to stop. So we're not gliding or anything else that the physics engine tends to do whenever you are normally moving or moving an object, because they are using some sort of drag and everything else. So now then, there's one other thing we have to do. So now if we run this again, I can kind of show that. If I jump, I can just keep jumping. And obviously we don't want to just allow our player to jump forever. So in order to change that, we need to check if we're on the ground. So now this method is all within fixed update. All of this is happening. However, we can actually do something different. So we're going to go ahead and extract this into a new method. So this is all going to go within our handle movement function. And we're just going to call it. So now handle movement, it works the exact same. If you ran the code right now, it'd do the exact same thing. However, here we're going to check the ground. So all we have to do for this is just add a method, and we need to make this also change our variables in order to modify this condition, or in order to change whether this will work or not. So now how are we going to do this? So it's actually really simplistic. We're going to also be adding a bool, and then we're going to use some raycast out in order to see if we're on the ground or not. So in order to do this, we're going to have a raycast hit, and so now this will store the information about our hit, and this can be used for later whenever we want to handle angles. That's not going to be handled in this video, but in the next video I'm going to be showing how you can handle angles and handling slopes that you walk up. However, for this video, this variable is actually going to go pretty much unused. So if physics.raycast, and so now we need to tell the physics engine how we're going to be raycasting. So we want to raycast from our origin point, which is going to be this point, and then we need to actually modify our origin just a little bit. And the reason I do this is because of how I have my pivot. So my pivot at the moment is actually at the 0, 0 right here, and then our capsule is all the way up here, and it's actually this collider here that matters. However, this is up here, and so although this will work probably just fine for most of the time, there could be instances in which you miss the actual raycast hit. Now, if you wanted to, you could actually change this to where the pivot is in the middle of your pill looking shape here. And so if it was in the middle, you would just stretch out your distance a little bit more. However, you wouldn't have to worry about this next part I'm doing right here. And I can kind of show how to do the other way, where you set the pivot of your character in the exact middle. However, for this, we're just going to do it like this. So we're going to say vector3 dot up, so along the up direction, times, and we're going to do a very small value like that. So this just kind of nudges up our pivot point a little bit. Then we're going to tell it the direction, which is going to be vector3.down. Actually, I always do a negative up. It's the same thing, but whatever. And then we're going to say that the max distance is going to be, you know, something small. So like 0.5f. So what this is going to do is it moves up our origin just a little bit, and I'll make that more clear by doing that. So it moves up our origin just a little bit. It shoots the direction down, and it goes for this amount of distance. And one other thing we want to do is we want to incorporate our hit here, which although is not going to be super important for right now, we do just want to have it for later, so that in the next video, whenever I show how to actually handle sloping angles, it'll work out just fine. So now we can kind of see here the origin, direction, the hit info, and the max distance. So we just want to say if this is true or if this is not true. So raycast gives back a bool here to say whether it hit something or not. And so if it did hit something, we want to say is grounded is equal to true. And if it didn't hit something, is grounded is equal to false. So if we are grounded or if we are not grounded, it just modifies this variable accordingly. So now where are we going to use this? Well, we can't actually use this in the inputs. And the reason I say that is because in the inputs, the update method could be called before our actual fixed update. And so if we're on the ground, and this is very nitpicky, but if you're on the ground but only barely hitting it, so like if you're still slightly in the air, but the raycast would normally be triggered. So if the raycast would normally be triggered, then we shouldn't jump at all. However, since how this is running is update and fixed update, sometimes this update will run before this raycast ever gets called. So even though this would be true, this changes first. So now we jump. And so rather than doing it in the input, so you could do this, and this would work fine. However, actually it would actually be is grounded. It would be this. So you could do this way, but I would recommend instead doing it down in here, because this check ground happens and then the handle movement happens right after. So what we want to do is we want to allow the jump to be triggered, and then we want to say if is grounded, and then we'll just do this. So as long as we're grounded, then we'll change our velocity. If we're not grounded, so if this jump is true, but we're not grounded, nothing happens, but this still gets turned to false. So it'll still use up your jump, but nothing will happen. So this should work just fine. And if we just run back into Unity, we can kind of see this working. And so I'm pressing space and nothing happens until I land. So I would like to just show a little bit of how this part is working, more or less, so you can kind of get a visual idea as to what's going on. So on draw gizmos, and we want to say gizmos.color is equal to red. That's color.red. And then I just want to say gizmos.drawLine from, so what we're going to do here is we're going to just take this, and so we're going to tell it the origin point, and then we're going to say the transform.position plus this, actually we could just repaste it, this, so this origin point to this origin point, which draw literally nothing, but then we take vector negative vector 3 dot up multiplied by 0.5. So what this portion is doing, so this is where our origin is, so that is this part right here, and then what this is doing is it's saying from this origin point add on this portion here, and that's actually what this is actually doing is this times, so multiplying by this. And so now we'll just draw that up. And if we just run back in, we can actually kind of see it. So let me go back to that. And I'll just kind of click off. So you can kind of see this line being drawn now. And you can kind of see just up inside of our model here. You can see it's actually right here rather than being right at the bottom here. And the only reason I did that is because that ensures we don't accidentally miss it, accidentally shoot our way through it. So here's what we're also going to do. This is a really long line, so I would actually suggest something more like maybe that or that. So I'll just do that. And so now that's a significantly smaller line, which is better, more accurate for whenever you're playing. So of course it still works the same, so nothing changes. I'm still going into the ground enough, and I should be able to jump off all of these objects as well, so I am jumping off that object as well. So yeah, that is our basic functionality here, the basic FPS controller. If you watch the next video, I'll show some other kind of mechanics here. So this check ground will also check our ground angle, and then prior to moving we'll actually check that at ground angle and see whether we can move up, and we'll kind of scale our velocity based on that angle. Another thing I'll also show is air control. So if you're in the air, how you can change the movement, as well as whether to give air control, also whether to nudge the player movement or to actually absolutely change it. So if you're in the air, you can either change the movement entirely, so similar to what we're doing down here where we're actually just changing the movement entirely, or you can have the air control nudge it. So it takes whatever your last jump value is and then moves it a little bit, just nudges the velocity a little bit. So if you like this video, like and subscribe for some more, and see you guys later.